Hello, my name is Kennedy Ko, and today I will provide you with a step-by-step explanation on how to answer an advanced functions math problem. The math question I will be answering is on page 274, number 9 in the Nelson Advanced Functions textbook. The question is, the function it equals 15t plus 25 over t gives the value of an investment in thousands of dollars over t years. A. What is the value of the investment after 2 years? In order to solve this problem, we must sub in 2 for the variable t, since the question implies that t represents years. After subbing in the value, we resort to simple mathematics, multiplying 15 by 2, which equals 30, adding 25, which gives us 45, and dividing by 2. The answer is 27.5. However, looking at the question for reference, it states that the value of the investment is in thousands of dollars. Therefore, the value of the investment over 2 years is amounted to $27,500. What is the value of the investment after 1 year? We use the same strategy in question A for question B. The only difference is that we sub in 1 for t instead of 2. The final answer is $40,000. C. What is the value of the investment after 6 months? The same strategy in question A and B is implied here. However, question C asks for months, when the value of t represents years. In this case, 6 months is half a year. Therefore, we could sub in 0.5 for the value of t, as the half of 1 is 0.5. Now we use the same method used in previous questions. The final answer is 65, so therefore, the value of the investment after 6 months is $65,000. D. There is an asymptote on the graph of the function at t equals 0. Does this make sense? Explain why or why not. This problem is identified in Unit 3 of the Advanced Functions course. To backtrack, an asymptote is a line that continually approaches a given curve but does not meet it at any set distance. Here is an example of an asymptote. And here is an example of the graphed function. As you could see, there is no horizontal asymptote at 0, but there is an asymptote at 15. But we don't need a graph to figure out the asymptote, we could just look at the equation. In order to figure out the horizontal or oblique asymptote, we must compare the degrees between the numerator and the denominator. Here are the rules that will give us the asymptote. If the numerator contains a lower degree than the denominator, the horizontal asymptote will be at 0. If the numerator and the denominator contains the same degree, the horizontal asymptote will resemble the coefficient. If the numerator contains a higher degree than the denominator, there will be an oblique asymptote in the form of y equals mx plus b. In this case, the numerator contains the same leading degree as the denominator. Because of this, the horizontal asymptote will correspond to the coefficient. Therefore, there will not be an asymptote at 0, but at 15. F. As time passes, what will the value of the investment approach? Going back to the graph, we can see that the curve approaches the horizontal asymptote. The curve never passes the asymptote, indicating that the asymptote is where the investment will eventually approach. Therefore, since the asymptote is at 15, the investment will approach $15,000, as the question previously stated that the values are in thousands. What profession would this question be applied to? We can relate this problem to the stock trader profession. Stock traders are investors in financial markets who make profits by taking advantage of price fluctuations on market stocks. A stock trader would not be wise to take part in this investment. As shown by the graph, the investment decreases over time. I hope you enjoyed and learned from my math explanation. Thank you for watching.